So, we are able to actually build various things here. This, as the machine builds up, it will show you the way the what do you call whole thing is built up. You can see partly the inside of the object. Why is it required? In our case it is open and we are able to see without too much of a problem. But if you are to make something where the inside was not clear, that is a very classical example is you have a cube and inside the cube you have a ball inside which is rattling inside. Not very long ago it could not be made, or a lot of tricks were involved. Now you want to make a cube with a rattling ball inside, build the whole thing in one shot. Or I have shown you a epicyclic gear train. It looks nice after it is finished, even in the screen it looks nice. But in between when you want to do, there is a planetary carrier, one triangular planetary carrier is there, if you recollect. Is the planetary carrier, is it rotating or it has got jammed? The only way to see is see the inside view. So, I will go on to the next thing. This is the actually layup process as which it is being done. This is the bottommost part which this is probably a support layer. Two things you see here is we have a full support of the whole object and outline is shown here. You see there is the outline, and if you see a little closer, can you see here how material is being built up for a support. It is the same, it is almost like those puzzles. Do you know where the child holds the balloon, or do you know how to get out of this maze or anything? Almost like a maze. This whole thing now has come here, it has go to this, it has gone here, and one thread has stopped here. You have seen this. Then there is another thread, probably this thread belongs to this corner, remaining thing is this. This is a reasonable way of building a object, and you see here even the topmost line, no, it looks a little quite a lot like the puzzles, and in fact we can give the puzzle and see how well it does. Next picture will show you a little as things are getting built up slowly. You see that in case there is a solid, the depending on the type of the machine, depending on the type of what do you call preferences you set and so on, it is very rare that the whole solid is made into a mass. If you have to make this, it is not correct to make a big lump of it like this and do it. It is easier if you make a honeycomb structure here, except it is a 3D honeycomb structure. So, what you see there is part of the honeycomb structure which is being built up. So, you saw the bottom layer, then the in between to build up the thickness we have those layers. Oh, next you see what is happening. Already it is somewhat closed and 3 of the features we want are being built up. And what you see there is probably the support material, and anyway I am not very clear because I will, when you go along I will explain to you how this goes here. That black stuff now is the actual material, remaining is the support material. You see here slowly as things keep building up, this is almost towards the end. This is the actually finally built material. This is all how the material flows, how the thing stays inside, and you see here in fact it is a single filament which as much as possible they try to join together, and in the end you have a beautiful part which satisfies your condition. I hope this is the last one, yeah. This in between as things are being built up. This is a final cover and we are done. And the same thing, and in the inside if you see how these things build up and if there is any clash or anything, that was a 2-dimensional from the top how the layers are built. Instead, this is a similar one but when made with 3-dimensional creations. Eventually, this is what the printing looks like. So, I hope it has been reasonably what do you call explanatory. If you come back to this main monitor, you see here several types of I hope my video plays. There is a little problem in downloading the video. I had not checked. Pardon me if it hangs. Yes, my computer does not seem to be able to. Yeah. It is a very simple thing. That object is a belt buckle. This machine we have will try to, when some job is running, I will see whether I can run the same thing for you. And in this case, in fact, we have two materials, one support material, which is one type, and then the actual building material. So, both are fed into the same nozzle and the nozzle goes around. Right now, probably that support structure is being made as part of the belt. See that you can see thing as it being built up. One of the things, first thing you will notice is there is a z-axis movement also, and to clean it, it goes a little, there is a small wire brush which comes and cleans up the corners. So, we have a support structure and then at the top we have the actual buckle, and in the case the material itself has a little springy properties. The way the design has been done, it is very easy, and the least amount of trouble it comes there. Then you go and put it in a water based ultrasonic cleaning system. It nothing, water and probably some minor chemicals are added, a little like a soap solution or something to reduce the or to control the viscosity. Eventually I have a clean part which serves as well as the regular part. So, this is almost like a demonstration piece, and if you can just sort of smoothen out the corners, it goes and snaps itself extremely well, strong enough also, which is probably one of the nice things which you can do with a 3D printing machine. So, I think this should be illustrative enough for us. Seen here. What we need to observe is, you see this small layers here. Contrary to, not contrary, I keep repeating, there is a what you call fixed resolution and so on. So, if you want parts to look very near the original, you have to give high resolution. Alternatively, you can try to apply some other filler material and sand it off. So, various types of the same thing what you are likely to use with the metal, so called metal paste or any touch up compounds can be always used, and afterwards by hand if you try to touch up these things by hand, you can have products which are as good as the original, but this is the real things. Normally this is about the resolution and the type of things that we can get. So, a little bit of search I could find it, and I am happy to share it with you. No, not playing. This is the other bigger thing I have shown you. Instead I had recorded it, and I just thought I will show you this. You have already seen it, and then it is very much possible for you. This is exactly how that handle has been made. Yeah, this is about what we can see. Now, if you go back here to the YouTube, you will see very interesting parts, including comparative statements between what are the different types of 3D machines which are available in the market. And if you are one of those lucky people who have a what you call very good this thing, you see here those kids are playing with a bionic hand, all printed at home, and there is a quadcopter printed at home, and you have all sorts of even anything you want, you can probably make it. The core thing about it is that filament, how you push the filament into this. Secondly, some objects like this car parts and all that, probably it is nice to understand and how well you can build those things. So, one of those things I feel it is worth for you to see it, and right now it is not very expensive, it is available in India also. All that happiness does not come naturally, the seller is selling the happiness. Oh, it keeps going like this, saying how to print a small object and so on, but when you come to technical objects, the design is very important. Not many what you call designs are available. If you remember in the slide which I wanted, I mean in the that first picture what I showed you, lot of these things were so people go about and imagining things, and maybe you can attend conferences, maybe you can attend try to make what best you can. And these days is available as a service. So, all sorts of objects can be created, and you can show how these things, something is nested in the thing, and then how it rotates, you can see there. This was not possible at all once upon a time. A 3D gimbal gears are all interconnected, one drives the other and so on, and then beautifully you have. So, I suggest you see it at your leisure. I am sure very interesting things are there. This is the one I wanted to show you. Now, whenever we do a small modification, before actually firing the job, we will make what is called the STL file. When you make the STL file, the amount of time required for the job to be built, and then the cost of the material, and the weight of the weight of the material is usually automatically calculated most of the time. No, print time, you see there, that simplest box what you are talking about takes more than 1 hour. It is a very tiny thing. The size was 30 mm, or I am sorry, it may be 40 mm by around 25 mm by 25 mm. It takes more than 1 hour to print, and the overall volume and then the mass of the object, it is calculated there. In some places it is not very critical, some places you need to work on it, and every alternate option you try, you can easily see how the print time varies. It is a complicated thing, it takes much longer, and if you have spherical or 3-dimensional affairs, every time you can go there and make your own what do you call things depending on the local thing here. Now I will exit this, go back to my other computer where the 3D software is resting. I will try to open this. So, if you see this that part which I had created and I was trying to showing you at that time, you see here you see I had shown all this, and I will see whether this is best. After having made this, when we save this, this is where actually it comes to the next part, but still I will try to show as best as we can. We end up with the options here. There are stereolithography files yeah. That is a mesh part that has been made. Now, if you see here that why a lot of that circus was made was to see if this mesh can be simplified and how well it actually builds the parts. So, in real life all 3D depends on a mesh of some sort of the other, there is no other way of making anything. You see here, now I have two things. While it looks simple, this is what I call the other part, while it looks simple, the way the mesh has been generated, the files will become bigger and bigger, and actually if you take a very complicated part, making this will be a real what do you call, it may be a challenge. So, it looks okay once the rendering has been made, but actually when you want to do the building, I am not very sure how well the part will come. To help us create in this mesh, it is much easier to make things which are planar. And if you look at the thing, this is typically a stereolithography file which all the things print. So, if you have a planar or any plane what you see here in space, 3 points only can be planar under all conditions. The moment you enter a fourth point, then it not be in one plane. So, if you have a square, I mean what you call a rectangular plane like this, you will notice all the 4 corners we have something, we can always bend it like this. The moment you bend it, it has become 2 squares, I mean 2 what do you call triangles. You have seen this, no? This is typically one of those mesh triangles. It looks a little like a sandwich, and all surfaces, all solids, everything is built of those things like that. Only then we can make these things very, very practical and interesting. Only problem with this is the resolution. So, resolution still is a problem, and after having printed it, you have to take it out and finish the objects. When you finish the objects, I am sure the things will look, better and better and better. So, you see here, so with a little bit of practice, probably you can start making things which are optimum. While it looks easy, while creating the drawing, you just make a series of using 3D primitives like a cylinder and a prism and something. Eventually, when you construct it, we end up with files which keep getting bigger and bigger and bigger. And this particular surface file is required for you to build any, what do you call, any other intelligence, including various types of drawings. Anything you want has to be made on this. So, if I come back here to this old printed circuit board, in principle I can create a 3D object here, or I think I showed you yesterday, I showed you, two types of things were there, same thing. See, that and this look a little similar, except this, if you see the location of this, what do you call, mounting hole, you see with respect to what do you call this and all, the mounting hole is here. You go back to the other one, the mounting hole may be somewhere else. So, it is you need to work about how to make those things compatible, and things look very, very similar at one stage, but eventually they are not compatible as it is. So, for this what you call session, I will stop here. We will continue afterwards, and I will see if it is possible for me to take this small job and then get it what you call printed on our premises and get a video of the printing. So, thank you. I will stop here.